In the last few segments, we've come to understand the effects that excessive hard parsing can have on the performance of your system. Let's now turn our attention to how to write SQL statements that will be soft parsed rather than hard parsed, and how we can incorporate these statements into our applications. For an incoming SQL statement to be matched to a SQL statement and execution plan already in the shared SQL area, the two statements have to match exactly. This includes column order, the order of predicates in your where clause, and even extends to whitespace characters in the statement and what characters are in upper and lower case. You can think of this as if you called string.equals on the two strings of the SQL statements, one string being the incoming SQL and the other string being the statement in the shared SQL area. If string.equals would return true, then the statements match. In effect, what we have here is a character-by-character comparison of the two strings, and only if each and every character matches are the two SQL statements considered to be equivalent. Let's take a look at a few examples of this. On this slide, we have two queries that are each retrieving grades for a student in a particular term, and in this case, the student and the term is the same between these two queries. These two queries are exactly the same, except for the fact that in the first query, the name of the view is in all lowercase, while in the second query, the name of the view is in all uppercase. For the purpose of determining if the two SQL statements match, character casing counts, and so Oracle would regard these two SQL statements as different statements and would hard parse each one. In this slide, we have two SQL statements that are very similar to the one shown in the last slide, and once again, we are querying the view for grades of a particular student. Notice, however, that the order of columns is different between the two queries. So even though these two queries are in fact returning the same columns and therefore the same data, the fact that the column lists are in different orders means that Oracle will regard these two queries as different and hard parse each one. It is important to consider, though, that when we write an application, typically we define the SQL our application uses in some sort of string in the data access class, and then we use this string almost like a template that we plug values into and generate the SQL we're going to run against the database over and over again. So generally speaking, we don't see issues where a statement is run once in uppercase and the next time in lowercase and things like that. It's just important to be aware of that Oracle does match these statements exactly, and you do want to pay attention to all the little details like character casing, column order, and spacing, especially if you have any code that dynamically generates SQL. What is more important for us to focus on is that using literal values directly in SQL statements causes the statements to differ and therefore be hard parsed. Let's see what we mean by this. Consider the two SQL statements shown on the slide. Once again, each of these statements is querying the view to get student grades for a particular semester, in this case the fall of 2013. The only difference is that they are querying the grades for two different students. The query on the top is getting the grades for student 1, 2, 3, 4, 5, and the query on the bottom is getting the grades for student 6, 7, 8, 9, 0. Functionally, these two queries are exactly the same. They are returning the same columns in the same order. They have the same predicates in the where clause. The only difference is which student grades will be returned for. However, since these queries are directly specifying the student ID in the where clause as a literal value, Oracle will see these two queries as separate and distinct queries and will hard parse each one. The reason why is because we have specified the literal value of the value we want in the query directly, and again, if we called string.equals on these two strings, we would get false. So in the eyes of Oracle, these two statements would be regarded as different. This applies not just to the student ID field, but to any literal value that can vary in any predicate in the where clause. In this case, I've changed the query so that in both instances, we're retrieving grade data for student 1, 2, 3, 4, 5. The first query is getting grades for the fall of 2013 term, and the second query for the spring of 2013 term. Again, these two queries are functionally equivalent. We're just varying the term in which we're retrieving grades for. However, Oracle will again see these two SQL statements as different statements and hard parse both of these. You can start to see the road we are headed down here. If we write our SQL statements with literal values like this, every time a different student logs on to our web application to check their grades, or a student checks their grades for a different semester, we're going to end up with what Oracle considers a unique SQL statement and wind up hard parsing that statement. And as we've talked about, that is the situation we want to avoid. What we need to do is to rewrite our query using bind variables. To do so, we're going to replace the literal values in our where clause with this syntax that represents a bind variable. In Oracle, the syntax that is used is a colon character followed by the name of the bind variable. So you can see in this statement, we're specifying two bind variables, one for student ID and one for the term code. When Oracle parses this statement, it sees the bind variables in the text of the SQL statement and not the actual values. So therefore, the text of the SQL statement is the same each time. Consequently, the statement will be soft parsed on each time it is run after its initial execution. What we want to do is to use a bind variable for any value in the where clause that can vary on different executions of the statement. In this case, we would expect that both the student ID and the term code would vary as the statement is run on behalf of different students looking at their grades in different terms. So both of these values need bind variables. When you submit a SQL statement that uses bind variables, you will also need to provide the actual values that Oracle will need to plug in when it executes the statement. Let's take a look at some application code to better understand how this is done. I'm in Visual Studio, and we're taking a look at some C# code. This code is part of the demonstration we'll run in a few minutes to help us understand the performance implications of using bind variables. This is a simple data access method that takes in two parameters, a student ID and a term code, and it's going to return a list of course grade objects, which is just an object that encapsulates all of the grade data inside of it. Looking at lines 23 through 25, we see the text of our SQL statement, and notice that the where clause, we aren't specifying the student ID or the term directly, but we do see our bind variables. Then, as we move down and look at lines 28 through 31, this is where we set the values of our bind variables. On our Oracle command object, there's a parameters collection, and what we'll do is we're going to new up two Oracle parameter objects. Those objects are going to contain the name of our bind variable and of the value, and then we're going to add those objects to that parameters collection on the Oracle command object. At a minimum, you need to specify the name and the value in the Oracle parameter object. There are other items that are available though for you to set, and these include things like the data type and the size and precision for numeric values. If you want to go ahead and set those, you can access them either through some overloads on the constructor or through some properties. So let's go ahead and set a data type right now. So student ID parameter, we actually want to use the Oracle DB type property, and this is an integer in our database. So there we go. There are a couple of other things that you should know about using bind variables in your application. First of all, you need to add an Oracle parameter object to the parameters collection on the command for every bind variable that is defined in your SQL statement. If you forget one, your program will throw an exception when it's run, and the message you'll get will be something along the lines of insufficient values to bind into your statement. Second, you need to add the parameters to the parameter collection in the same order that they are listed in your SQL statement. That is, when Oracle matches the parameters up with the SQL statement, it actually does so positionally. It's not looking at the names. So if I were to go ahead and reverse the order here, and I'll do that right now, I'm going to put term code first. This code here actually would throw an exception. Now there is a parameter that you can set on the Oracle command that says, I don't want to bind by position, I want to bind by name. And the name of that parameter is bind by name, and you just simply set this property to true, and then this code will be okay. Oracle will match these up by their name and disregard the position, and this code will run just fine. I realize this is C# code, and not everyone is a C# developer, but generally speaking, things are going to work in a very similar fashion in all languages. In Java, what you'll want to do is you'll want to use the prepared statement class, and on the prepared statement class, there are going to be methods to add parameters onto that object. In other languages, consult your documentation for how to add parameters into your SQL statement, but generally it's going to look something like what we have here. I want to take a moment to contrast this code with some data access code that uses literal values. So I'm going to jump over to the other class called literal values DAO. This is the same method as we had before, where again we're passing in a student ID and a term code, and you'll see that the major differences are in the SQL statement that's defined on lines 25 through 27. Here, we're inserting the values passed in directly into our SQL statement using string concatenation. And then it's this SQL, with the literal values included, that's being submitted to Oracle each time. You can clearly see here that as we pass in different parameters to this method, then we would create a different SQL string and submit this SQL string to Oracle each time. There are a couple of problems here. The first issue is that, as we've talked about in this module, each one of these SQL statements is distinct and ultimately going to result in a hard parse up in our Oracle database. The second problem, though, is that anytime we are forming up SQL using string concatenation and inserting values passed into us directly into our SQL, we're vulnerable to SQL injection attacks. When we use bind variables, the Oracle driver will automatically escape any special characters that are in the value that's passed in, so our SQL statement is protected against any values that were submitted with malicious intent. With literal values, though, that string is just passed on through to the database, and this poses a very serious security threat. Now, using bind variables doesn't mean that you shouldn't implement other good security practices like validating your input in your application, but they do offer one more level of protection. There are a couple of final items that we need to cover. First, pretty much all of the major object relational mappers in use today already use bind variables implicitly. So if you are using Entity Framework or in Hibernate, your application is already using bind variables and you should be in good shape. If you are using an ORM, you might be tempted to think that bind variables is a topic you don't need to worry about. However, while new development might be taking place using an ORM, a lot of times we have to support existing applications in our jobs. And you want to make sure that these applications that are just using plain old ADO.NET or JDBC are using bind variables as well. And if they're not, you want to get those applications uplifted. One reason why that we just covered is the security concerns around SQL injection attacks. The other reason is that if you have one or two of these applications out there in your organization, these applications by themselves can use up a lot of resources on your Oracle server and cause contention around the shared SQL area. So in that way, these existing applications that don't use good practices can impact the performance of all of your other applications that are using that same Oracle instance.